All right, welcome. This is part 2 of our electromagnetic spectrum or electromagnetic wave lesson. So let's get started. Okay, so what exactly is the electromagnetic spectrum? So we talked about electromagnetic waves, which is it could travel through a vacuum, and it's the electric and the magnetic fields working together to create that wave. Of the electromagnetic spectrum is just the range of all of those different types of electromagnetic waves in order of increasing frequency. Okay, so how many wavelengths are happening in a given time period? That's how it's measured. Okay, so the lowest one is radio waves, then microwaves, infrared waves, visible light, ultraviolet rays, X-rays, and then finally gamma rays are the highest frequency, so they have the shortest wavelength. And so let's get started as to what they are all about. So what exactly do we mean about short versus long wavelength? The shorter wavelength is means that there's going to be higher frequency because from hump to hump or from crest to crest, that length is shorter, so that means there's going to be more wavelengths within a time period. With a longer wavelength, it's a longer hump to hump, so it will be fewer waves per amount of time. Okay, so again, shorter wavelength, there's going to be a higher frequency because there's more waves in a given amount of time, which means there's going to be more energy. Okay, we talked about that last lesson. And then with longer wavelengths, there's lower frequency because there's not as much waves per amount of time, so that means there's less energy as well. Okay, so let's take a look at the electromagnetic spectrum. This is a chart that we have. So energy increases from the left over here all the way from the right all the way to the left. As we see, the shortest wavelength is at the left. That means that it is at the highest frequency. And then the longer wavelengths are at the right, which means that it's at a lower frequency, so a lower energy. Okay, so again, lowest frequency is radio waves, highest frequency is gamma rays, and then in between those are microwaves, infrared rays, visible light is light that we see, ultraviolet rays, and X-rays. Okay. So first, let's talk about radio waves. That's the longest wavelength, so it has not as many waves per a given amount of time, and it has the lowest frequency, therefore the lowest energy. These radio waves are used in phones, so how we call people, television, so how we see things on the screen of our TVs, and radio, so things that we could hear from different distances. How we pick those up is how the towers are receiving those radio waves, and they transmit them to the next thing. So something is being recorded. Those waves are being transmitted to the tower. The tower is transmitting it to our TVs. Okay. Next is microwave. That's the second lowest frequency or lowest energy. We use microwaves in microwave ovens to warm our food up, and we also use them in radar detection. So like how they detect speed on different cars. So have you ever seen a speedometer? That's a radar detecting your speed. Next is infrared rays. Those are a type of electromagnetic waves that we can't see, but we could feel it as heat. So the things that we feel when it's hot outside, those are infrared rays. Okay, so we feel it as heat. So if we touch something as hot, those are the infrared rays that are giving off that heat. Next is visible light. Whoopsie. Next is visible light. Those are, again, electromagnetic waves that we could see. And just an example of how we see different types of light. The prisms split white light into the colors of the rainbow because that light is refracting, so it's bending. All of these different colors have different wavelengths, which is why we see all different types of colors. You could also see this if you ever have like a crystal or something hanging up and light comes through and creates a rainbow somewhere else. That's because of refraction. Okay, this is also how rainbow forms. So light is going into those raindrops and refracting and bending from that water droplet, and then we see rainbows. Okay, next is ultraviolet rays. We're getting closer to the higher wavelengths. Ultraviolet waves are the rays that we get from the sun. We use sunscreen to protect these, to protect ourselves from these harmful rays. So there are 3 different types: UVA, UVB, and UVC. UVA, those are longer waves than UVB or UVC. Those go deep into our skin, which causes a great amount of damage and can lead to skin cancer, which is why we put sunscreen on. UVB rays are in the middle between UVC and UVA. They can cause tanning, but also it can cause signs of aging. So if someone's goal is to be tan, they're looking for those UVB rays. Okay, and then UVC, they're the shortest ones, and they usually don't penetrate the earth because of the ozone layer. It's protecting us from those UVC rays. Okay, so there's UVA, UVB, and UVC. UVA and UVB are the ones that are reaching us. UVA is the one that causes skin cancer, and UVB is the one that causes tanning. Okay. Next is X-rays. X-rays have more energy than the previous ones we've been talking about, so they could penetrate most matter. So they can penetrate a bunch of different objects. But more dense matter, like bones, for instance, can absorb these X-rays. They can absorb those waves, so they can be used to create an image because they're being absorbed. So that energy is being absorbed, which creates that image that we see in X-rays. Okay, finally, there is gamma rays. That's the shortest wavelength and the highest frequency. So it has the highest energy. So since it's the highest energy, it can be dangerous, but they're also used to treat cancer. They target gamma rays at the tumor cells of cancer, which damages the DNA because the energy is breaking apart that DNA. But it could also damage our DNA, which is why this radiation is not really that great, but it is used to treat cancer. Okay. So we just went through the entire electromagnetic spectrum. Thank you for watching. I hope you learned something new, and I will see you next time.